Year 12. I just want to walk you through some of the solutions for the Year 12 Advanced third task for 2023. The main thing I found in looking at these, and I looked at the first booklet after the multiple choice, was that most of you were not looking at the formula sheet. And a lot of you, or most of you, lost a large amount of marks primarily because you didn't do what the formula sheet told you to do. You were trying to invent your own rules and you were doing things basically incorrectly, which we could not allocate any marks to you for. So let's have a look at the questions. Let's have a look at the first one. This one's fairly straightforward. It was worth 1 mark. This was done fairly well. But I would have been looking at the formula sheet to figure out what I had to do when I differentiated an exponential, and that tells me that I need to differentiate the power, which is sine. When I differentiate sine, I get cos, and the e to the sine x goes back down. So that was worth 1 mark and was probably one of the best questions done on that first booklet after the multiple choice. This question, the next one, was done really poorly. So this one's looking at differentiating a log. Now, it was a tricky log because we had a function that had an upper and a lower. But you need to know your log laws. And there was actually 2 ways that people attacked it. Okay, and the first one was to use your log laws that says when we divide, we can use a subtraction. So we were going to be doing log e of x plus 4, take away log e of x minus 3, in which case each of these is very simple to do. It's the derivative on the function. So the derivative is 1 over our function, which is x plus 4. Take away the derivative over the function. And then you needed to get that into a format that was a little bit neater, which would look like this. So changing our denominator to the multiple of what we had at the top, cross multiplying, opening brackets, and we would have ended up with minus 7 over x plus 3. X plus 4, x minus 3. That was one way. The other way some people attempted to tackle, which a few people got out, which was a little bit messier and harder, was to think, well, what do we do when we differentiate a log? We go derivative on the function. So we needed to find the derivative of what this was and put the whole lot over this again as our function. So you basically had 4 things popped on top of each other and you needed to sort that out. And most people who did it that way got it wrong. There was a couple that got it right that way. Most people who did get this question right did it using your log laws. And the way that was marked, because it was a 2-mark question, was if you used the log laws and differentiated correctly, you got a mark. When you left it like this, you had to go all the way down here to get your 2 marks. If you have correct differentiation of this using the quotient rule, so I looked through your working when you did it the other way and allocated marks where I could. You got 1 mark for the use of differentiation of a log with incorrect differentiation of this part here, and 2 marks if you got it right all together. So I would suggest you go and practice this one. It's a very straightforward question if you split up using your log laws. And let's have a look at the next one. Okay, y equals 8 sine log of x. You can see here that x happens in 2 different positions. So there's a function here, there's a function at the end. You need to use the product rule. Those that attempted this generally did this one okay. There was, however, some people who used the product rule incorrectly and didn't copy it down from your formula sheet right. So I'm not going to go through it in massive detail, but if you let u equals sine of x, u dash cos of x, log of x, we get 1 over x. If you apply that using your formula sheet rule, this falls out and you would have got 2 marks for that. I gave you a mark if you did differentiate log of x and showed me somewhere that you got 1 over x, or if you differentiated sine and got cos somewhere, you also got a mark for that, but 2 marks to get the whole thing correctly out. Okay, the third one, determine the integral of 1 plus tan squared x for 1 mark. Now, what I would have been doing if I was you, I would go to the formula sheet, which I'm going to get up there now. So if you look at your HSC formula sheet and look under the integration section and you look for the integrals of your trig functions, you will see that you've got an integral for sine, 1 for cos, and 1 for sec squared x. Nowhere in that sheet do you get an integral of tan x or tan squared x. So that's telling me, okay, I can't straight out integrate that. I need to do something first. Be the first thing that you're looking at. The second thing you should be noting is there is a squared there. When there is a squared, you need to remember your rules for trig identities. So you learnt last year that sine squared theta plus cos squared theta is equal to 1. There are two other rules that go with this, with squared terms. They're not on your form. That one's on your formula sheet. You need to remember the other ones. So I don't memorize them. The first step I do is let's divide that by sine squared x and then divide it by cos squared x. I know that I need the cos squared x1 now, so I'm going to show you that. So if I divide everything by cos squared x or cos squared theta, sine squared theta on cos squared theta is tan squared theta. Cos squared theta on cos squared theta is 1. And 1 on cos squared theta is sec squared theta. So that's the one we need for this question. We can also divide this by sine squared theta to get our other rule. It has cot and cosec in. So wherever you see a 1 plus tan squared theta or a tan squared theta, you're going to go back and have a look at the rule. I've got a 1 plus tan squared theta, so that's sec squared theta. So I get the integral of sec squared theta. The reason I'm going on a lot about this is a lot of people just gave me sec squared theta as the answer. It's not the answer, it's the substitution. And then when you go to your formula sheet, there is an integral for sec squared theta. It is right here. The integral of sec squared theta is tan theta. So we write in that tan theta, and we're always adding a constant because there's no upper and lower limits. That was just worth 1 mark. But sometimes those 1 mark questions make a big difference in your overall ranking and your overall positioning. Now this one here, you need to be able to look at a question like this and go, it's a log. What you could do is if you pulled that 2x squared plus 5 to the top line as a minus 1, and you tried to add 1 to the power, you're going to get a 0. So that also should tell you, oh, I can't do that. That's a log. So what you're going to have a look at on your formula sheet is it needs to be in the format of the derivative on the function. And that's on your formula sheet. And when you get something in that format, it is a log. So if you have a look, we've got a function on the bottom line, which is 2x squared plus 5. And we differentiate that, we get 4x. We've got double that. We've got 8x, so there's a 2 out the front. So we've got double the derivative on the function. The formula sheet tells us that this should be in the form of log of that bottom line, or log of the function, and we've got double it. And we add c because there's no upper or lower. That was not done well at all. Now, you got 2 marks for the correct answer. You got 1 mark for recognizing it's a log, and a lot of people had a half out the front, or 4 out the front, or nothing out the front. So you didn't get that value, so your answer was wrong. So make sure you go back and have a look at those ones and practice as well. So let's have a look at the next one. So this one is worth 3 marks. So 3 marks for the correct solution for this one. A mark for changing the tan squared x. A mark for integrating sine properly. Or a mark for substituting properly. Overall, again, not done well this question. And it's similar thinking to the question above. You've got an integral sign and you've got a tan squared x. You go to your formula sheet. There's nowhere that it shows you that you can integrate tan squared x. You see a squared. You're going to substitute in. You're going to use the formula that I used up above. Okay, so we had, remember that sine squared, we had theta. We're going to do x in this case. Plus cos squared x is equal to 1. We're going to divide that through by cos, and we're going to end up with tan squared x plus 1 is sec squared x. But we only have a tan squared here. So if I rearrange this formula, I get sec squared minus 1 is tan squared x. And that's what's gone in here for my tan squared x. And then my sine 2x goes in here. What a lot of people did was they left the minus 1 and they just automatically went, oh, tan squared x is sec squared x. It's not. It never was. It never will be. You need to pop the correct substitution in. And once you've done that, now you can integrate. Okay, so if you did get to that point, then you generally did okay and you got the tan x minus the x. However, when you integrate sine, you don't get cos, you get minus cos, and you have a 2x here which you're going to divide by. So a lot of people put a plus, most people forgot the 2. That was the other thing that was done correctly. So if you didn't do those 2 things correctly, integrating the sine to the cos or integrating or substituting the tan for the sec squared minus 1, you didn't get any marks. The other thing I looked for was then if you did make those mistakes, did you substitute in correctly? Could I get you a mark there? Where I could, I did. However, you needed to substitute it in and you needed to do the right calculations and get the right answer. A lot of people, again, made mistakes with this negative sign. Didn't put brackets in and then forgot that that negative is then applied to all of these things within the brackets. So that was another major mistake that people made, which is a really simple one. I suggest that you put your pi on 4 and your 0 in exactly like the working out is done here, because then you're going to have less errors and then you can do a straightforward calculation and show your working. If I can't see your working, I cannot give you marks for that question. Okay, our next one is 9. Find the gradient of the tangent to the curve y equals 3 to the 2x plus 1 at the point 1, 27. Worth 2 marks. People who did this, and there was probably only about 10 people in the year that got this one out, made a big difference to their total mark. This is a really, really simple question. And again, I'm going to let you look at that and go, that 3 is not an E. That would be an A on the formula sheet. All you needed to do was go to the formula sheet, get the formula, do what it says, and you would have got that first line there for 1 mark. So finding the gradient of the tangent. Back to year 11, the gradient of the tangent is the first derivative. So let's go and have a look at the formula sheet. Look on the differentiation section, you will find this here. Y is some value with a function as a power. This would be a number like we've got as 3. It's not an E, we do it differently. Okay, the E's up here, that's how we do E. This is a value. So you needed to just go log of A on the derivative of the function that's up the top and then pop that function back in there. That would have got you 1 mark. So I can't stress enough how important it is for every single question for you to not guess what's on the formula sheet. They give that to you to help you. So once you had gotten this thing here, okay, log of the A, derivative of that power, which is 2, and then we write that down again, all you needed to do was sub in x equals 1. And that was it. Simple. Most people could not do that. And it was generally to do with this 3, not recognizing it was not an E and it was a different rule. Okay, question 10. A curve y equals f of x passes through the point 0, 7. Its gradient function is given by this. Find the equation of the curve. Now, a lot of people wanted to use y minus y1 equals mx minus x1. You don't need to do that. You have been given this info here that's going to help us find the C when we integrate. So we're going to integrate our dy dx to get y. And what we're going to get is x plus, this is where people made a mistake and had a minus in there. The derivative of sine is cos, but the integrated sine is minus cos. So we get a plus. We're going to divide by that 3 and pop it on the bottom. So we've got 6 cos 3x over 3, which becomes a 2 plus c. Then you're going to pop your 0 and 7 in, x and y. So we've got 7 equals 0 plus 6 cos 0 over 3 plus c, and we're going to get a 5. What you're going to do is pop that 5 up here. A lot of people didn't do that either. And show me what you get. Please don't expect me to pull out your information and figure out that you know what you've done. You need to explain it at the bottom. A lot of people didn't put y in there in any way, so I didn't really know whether you had a y or whether you knew that that was what you were getting. So you got 1 mark, or sorry, obviously 2 marks if it was correct, 1 mark for the correct differentiation, but an incorrect constant. So you needed to have this part here, not a negative in there because that wouldn't have been correct. And 1 mark if the constant was found from that differentiation. So if you, from integration. So if you integrated and put a C, but you integrated wrongly, and then you put your values in and gave me a C that wasn't 5, but you did the correct thing, and then you gave me a function at the end, you would have still got a mark. Nearly there. Okay, question 11. Differentiate e to the 3x cos x minus 3 sine of x. Now, there's multiple ways you could have done that. The easiest way would have been to not expand it. That was worth 3 marks. You would have got 3 marks for the correct solution. 1 mark if you recognised it was a product rule. Another 2 marks if you correctly substituted into the product rule with an incorrect expansion, or 2 marks if you expanded with a correct expansion from their product rule. So basically, you needed to show me that you got part of the way with this to get the answer.